In this lesson, we will learn about a couple and how to determine the moment of a couple. A couple is defined as two parallel forces that have the same magnitude but opposite directions and are separated by perpendicular distance. Since the resultant force is zero, the only effect of a couple is to produce a rotation or tendency of rotation about an axis in a specified directions. For example, imagine that you are driving a car with both hands on the steering wheel and you are making a turn. One hand will push up on the wheel while the other hand pulls down, which causes the steering wheel to rotate. The moment produced by a couple is called couple moment. We can determine its value by finding the sum of the moments of both couples' forces about any arbitrary point. For example, in this figure, couple moments determined about O is M equal to RB cross F plus RA cross minus F. However, RB equal to RA plus R or R equal to RB minus RA, so you can replace in this equation. This result indicates that a couple moments is a free vector, such as it can act at any point since M depends only upon the position vector R directed between the forces and not the position vectors and directed from the arbitrary point O to the forces. This concept is unlike the moment of a force, which requires a definite point or axis about which moment are determined. The moment of a couple is defined as having a magnitude of M equal to F times D, where F is the magnitude of one of the forces and D is the perpendicular distance or moment arm between the forces. The moment of a couple can also be expressed by the vector cross product using this equation. So, considering this example and using the scalar approach, here two couples act on the beam with the geometry shown. We need to find the resultant couple. According to our plan, first resolve the forces in x and y directions so they can be treated as couples. Add the two couples to find the resultant couple. The x and y component of the upper left 300-pound forces are 4 by 5 into 300 pounds, which results 240 pounds vertically upward, and 3 by 5 into 300 pounds, which results 180 pounds to the left. Do both of these components form couples with their matching components of the other 300 force? No, only the 240-pound components creates a couple. This is because the 180 pounds couple passing through a common point. Now resolve the lower 150-pound forces, which will result one acting upward and the other component acting to the left. Do both of these components create a couple with components of the other 150-pound force? The answer is no. So the net moment is equal to minus 240 pounds into 2 feet minus 150 pounds into cos 30 and to 2 feet. This results a moment in the clockwise direction minus 739.8 feet-pounds. In the second example, we will use a vector approach. A 35 Newton force couple acting on the rod. We need to find the couple moment acting on the rod in Cartesian vector notations. So our plan is to use this vector equations to find couple moments. We will set R as RAB and force F equal to 35 kN. Finally, we will calculate the cross product to find M. The position vector RAB from geometry is equal to minus 0.25J plus 0.1443 km. Similarly, the force vector. So using this couple equations and then taking determinants. So the couple moment vector is minus 8.75I plus 0J plus 0K Newton meters, which means there is only a moment about x-axis and there is no couple moment exist about y and z-axis. Thanks for watching.